Okay, so moving along. We've got some special limits here. And the special limit that we're talking about is based on the 1 over x. Okay? So I'm going to talk about these each a little bit. So the limit as x approaches 0 of 1 over x. What's our general go-to? We try to plug 0 in. What happens if I plug 0 in? You get 1 over 0 and I don't know. So what you need to do here, okay, is first of all, think about this from two different sides. Because if a limit exists, the same thing has to be happening on the left that happens on the right. So as x approaches 0, my graph has to be doing the same thing. Whether it's coming to a point, both going up, both going down, they have to be doing the same thing. So think about this as x approaches 0 from the left and as x approaches 0 from the right. So as x approaches 0 from the left we'd have like negative numbers, yes? You'd have like 1 divided by, say, negative 5, negative 1/5. 1 divided by negative 4, negative 1/4. 1 divided by negative 2, negative 1/2. 1 divided by negative 1, negative 1. As we keep going, if you do 1 divided by some decimal, what's happening to that number? It is getting closer to not just 1, it's going to go past 1. It's getting larger, but in the negative sense. Should have started with the positive one instead. Just realize that. Okay, because what's happening, negative 1/5, negative 1/4, negative 1/3, negative 1/2, negative 1. Those numbers are getting larger, but negatively. So that means this graph is going down. Okay. As you think about as x approaches 0 from the positive side, so that means as you put in positive numbers. It's still the same idea, right? 1/5, 1/4, 1/3, 1/2, 1. If you start putting in like 1 divided by 1/2, that's 2. 1 divided by 1/3, that's 3. So these numbers are doing what? They're getting larger positively. So what's happening at that point? It's going two different directions. So my limit, as you guys already started to mention, does not exist. If we look at this graph real quick, do you remember what 1 divided by x looks like? Remember that reciprocal? What's happening? As x approaches 0 from the left, my graph is going to negative infinity. As x approaches 0 from the right, my graph is going to positive infinity. Is my graph doing the same thing at 0? No, we've got 1 going up, 1 going down, so thus it does not exist. Now, look at B. The limit as x approaches 0, this time it's 1 over x squared. Again, if we put in 0, if you put in 0, it's 1 over 0, and it's okay, what's happening? So what am I going to say? Examine it from left and the right. Let me start with the positive this time. Just our brains all work, mine included, work better in the positive sense, right? I'm going to throw myself into that. So if we're doing numbers that get closer to 0, so like 1 over 5 squared, 1/25. 1 over 4 squared, 1/16. Okay, 1 over 2 squared, 1/4. 1 over 1 squared, 1. So those fractions were all getting bigger, yes? Now we're at 1. If you do something like 1 over 1/2 squared, when you do 1 divided by a decimal, you're getting bigger numbers. So this is moving up to positive infinity. What's different about using negative numbers this time?
There's nothing.
what happens when you square a negative? It becomes a positive. So earlier when I put in 5, it was 1 over 25. Now when I put in negative 5, it's still going to be 1 over 25. So the point is here that this is also going to positive infinity. What's that mean? If from the left it's going to positive infinity and to the right it's going to positive infinity, what does this limit approach? Positive infinity. Or in other words, yes, infinity. If you recall, we graphed this previously. Instead of one hyperbola piece, going down and the other one going up, they both go up. And since they're both going up to infinity, that's what makes it work. So you want to be careful about making sure you check things from both sides before you automatically say does not exist. Because these graphs appeared to have the same thing happening, but they really didn't. Now, C. The limit as x approaches 0 of 4x plus 8 over x plus 2. We did something similar to this previously. Both answers work. I heard factor and I heard plug in 0. In this case, it works both ways. Okay? You can plug it. Now, I am going to take a moment though. Do you guys know what we mean when we say factor? Yeah. And in this case, I get it. It doesn't make a difference. By all means, plug in that 0 and you're good. You're going to get the same answer. But if I factor, it's 4 times x plus 2 over x plus 2. What happens there? X plus 2's can cancel. And so now you're just doing the limit as x approaches 0 of 4. I can't say the Jackson way of 4, but. And so there's no, when you plug in 0, it doesn't affect, and so that is just 4.
Okay, never mind. I got it. I'm good now. Sorry, just a second.
Okay, so in other words, in this case, you guys that had plugged in 0 from the beginning, you got 4, yes? Because you got 8 divided by 2, and that is 4. The way I did it, I factored, canceled those. The limit as x approaches 0 of 4. Well, there's no x to plug into, right? So at that point, your limit is just the 4.
So will it always be like that, as in you can always plug in that or you can factor and it can get the same answer?
It should be. In that type of situation, where when the plug-in works, you could, there's also possible factoring. Now, next one. Limit as x approaches 3 of x squared minus 9 over x minus 3. What do you notice?
The top is a perfect square.
Yeah. If I plug in just 3 over 3, if I plug in 3, I'm at 0 over 0. And that's not okay. We don't have anything to do with 0 over 0. That's not an option.
No.
So, back up. What could we have done?
You could factor it out, and then the bottom would cancel out with one of the tops, and you just end up with x plus 3.
Okay. So, the top factors into x plus 3, x minus 3. That's good news, because now an x minus 3 cancels. And so now it's the limit as x approaches 3 of x plus 3.
Never mind. I said it equal to 0.
Okay, nope, I'm not saying equal to 0.
Sorry.
Okay, so now, how do I actually finish the limit? Put that 3 in for x, and so then it becomes 3 plus 3, which is 6. Yeah, don't do there's no studying that equal to 0. I love how you guys are so well trained, that's what you automatically do, but.
I got excited because I was really following really well, and then I got ahead of myself.
Okay. Backside. Oh, I love these.
Oh no. going, we're going to.
I don't know.
I don't think it's ever good to go.
Oh, dang it. Jack,
It
you said no.
depends if you can see it. Okay? If you can see it. Just give me a chance to explain that. Okay, guys. So all three of these limits are in a certain format. Okay? So, I mean, like right now, if I plug in 0,
Oh, I see.
I'm going to end up with sine of pi over 2 minus sine of pi over 2, which is 0 over 0. All three of these have that situation where if I just plug in, I'm at 0 over 0. So that's not an option. Okay? It's not like you can factor anything. Okay, guys. This relates to a limit that we have done a lot of. I've told you, even though we have an easier way now, you have to know the limit. Don't give me that look, Jack. Don't give me that look. What are these set up? What is this limit? This is definition of derivative. Do you see that?
I actually did.
Okay. Remember, definition of derivative is the limit, and it can either be h or delta x, right? So let me just write this down.
You don't have much time to do it.
5 minutes.
Yep.
Where's today gone? Okay. Thank you, though. Okay, guys. So, does this look familiar to these?
Oh, yes.
Okay. So, this first one, it's the limit as h approaches 0. What's my function on the first one? The function we're talking about is sine. Okay? Because remember, it's f of x plus h minus f of x. So, what this is the derivative of sine when x equals, what do they have in place of x? Pi over 2. So, first of all, what I'm going to write is definition of derivative. Okay, these are all definition of derivative. Now, in order to do this first one, we're not going to do anything with that limit. It is the derivative of y equals sine x at x equals pi over 2. So I'm going to, in our easy way, take the derivative of sine and plug in pi over 2. Give you guys a brief moment to write. Cassie giving me a look because she doesn't quite see where this is going. Doesn't like
something and I just didn't hear what you said.
Oh, okay. So it's not clicking, whatever I said. Okay, I'm going to walk through it. So my given function was y equals sine x, yes? We said it's the derivative of that. So what is the derivative of sine x? Cosine x. And then what was my x value here? Pi over 2. So we're doing the derivative evaluated at pi over 2. So what is the cosine of pi over 2? And that's going up 90 degrees, right? So it's left to right 0, up 1. This is 0.
Jen, do you have that whole unit circle memorized in your head?
Answer to this problem is 0. Okay, next one. The limit as delta x approaches 0 of natural log of x plus delta x minus natural log of x all over delta x. This is the derivative of what function? ln x at, do we have a value here? No. What do they have in here? If you always look at that last one, that's just ln x. So is there a value to plug in here? No. In this one, we're just doing the derivative of ln x. So we're doing the derivative of y equals ln x. Or I should say maybe f of x. Doesn't matter. So if f of x equals ln x, what's f prime of x? 1 over x. And the last problem. What is this? e to the x plus h minus e to the x. This is a derivative of e to the x. It just says e to the x in the problem, so again, just a derivative of e to the x. So, yep. Derivative of y equals e to the x. Well, if y equals e to the x, then y prime is e to the x. And I got it done before the bell rang. Yes.
Why was A 0? Why is it not 0?
Because we had to plug in pi over 2.
Yeah.
Because pi over 2 is right here, and the cosine of pi over 2 is 0.
That was impressive.
I'm getting soap, or like
Okay.
the whole thing like came off and I like caught it and I like put it back on.
Is that before or after I fixed it this morning? Okay. Because I fixed it at one point, so I don't know.
I still haven't heard that and I was like, that's probably what it is. It's probably just
I was really loud for that, though. Okay, guys. Remind me on Monday that we're gonna have 2 homeworks to check. I didn't remember that lesson being so long.